So good afternoon. Our topic for today is all about equation of a locus. Our objective for this lesson is to discuss and define the equation of the locus and solve the equation of the locus of the given curves. So the equation of the locus. A locus is a set of points which satisfy certain geometric conditions. Many geometric shapes are most naturally and easily described as loci. For example, a circle is the set of points in a plane which are a fixed distance r from a given point P, which is the center of the circle. So this is P1 xy. So assume that P is here. So the locus of the equation is, so let's say your circle, so this is your curve, okay? So from any point P from the circle, so this is the equation of your locus. Okay. So here are some steps in solving the equation of the locus. First, we assume the locus point P, x, y. So next, we're going to write the given geometrical condition. Next, we're going to use distance, section, centroid, and other formulas as per condition. Next, we're going to substitute in the geometrical condition. So simplify to get the equation of the locus. So let's have our first example. Okay, so find the locus of a point P such that its ordinate is 5. Ordinate means the y-coordinate of your ordered pair. Okay, so for our solution, so let P, x, y be the point on the locus. So given the ordinate of P is 5, which is y, which is equal to 5. So here in our graph, where is y, which is equal to 5, located? On the upper part of your y-axis. Yes, okay, this is y, which is equal to 5. So therefore, the required equation that we need is y, which is equal to 5. Okay? Next, let's have our second example. So find the locus of a point P such that the abscissa is 3. Okay, the abscissa is the x coordinate of your ordered pair of the linear equations in two variables. Okay, so for our solution, we let P x y be the point on the locus. Okay, so given the abscissa of P is 3, which is x equal to 3. So here in our graph, where is your abscissa or x is equal to 3? Okay, it's located on the right part of your x-axis or 3 units from the origin. Okay, so this is your x is equal to 3. Okay, so therefore the required equation is x is equal to 3. Okay. Okay, let's have our third example. So we're asked to find the locus of a point P such that its ordinate exceeds 5 times its abscissa by 9. Okay, so as if we're translating algebraic phrases into expressions. Okay, so for our solution, so this is always our first step. We let P, x, y be the point on the locus. So given the ordinate of P exceeds 5 times its abscissa by 9. Okay, so the equation that we need is y, which is equal to 5x plus 9. Just translation. Okay. So if you're going to graph it in our Cartesian plane, so graphing the equation y, which is equal to 5 x plus 9. Of course, we need at least 3 points. So this is the y-intercept, which is at 0, 9. So 9 units from the origin. Okay. Then, so 5x, which has the slope of 5. Okay, which is 5 units upward and 5 units downward. 1 unit, okay? So, okay, at least we need 3 points for this graph. Okay, so this is the graph of our equation y, which is equal to 5x plus 1. Although we can also add 5 units. This is also the same. So if we're going to continue this, that's y equals to 5x plus 1. Okay. The other 2 points we came at from the table of values. So that's to satisfy the graph of y, which is equal to 5x plus 1. Okay, let's have our first example. Or what I mean is fourth example rather. Okay, let's find the locus of a point P such that the distance of P from the origin equals 5 times its distance from the point 3, negative 2. So our solution, okay, let's, same step. We let P, X, Y be the point on the locus. Okay, let O be the origin, which is 0, 0, and A, point A, 3, negative 2 be the point. Okay, so let's graph this on the Cartesian plane later on. So we're given OP, so that segment OP, which is equal to 5 times segment PA. Okay, let's graph this. So therefore, if we're going to square it, that's OP squared, which is equal to 25 PA squared. Okay, because we're looking for the distance, so that's why it's squared. So if we're going to graph it, so this is the point O, which is our origin. This is point A, 3, negative 2, so it's located on the fourth quadrant. And P, X, Y, B, any point on our Cartesian plane. So it's as if you're forming a right triangle. Okay, so it's like a right triangle, so we're going to, as if you're using the Pythagorean theorem. Okay, so therefore, so you're using distance formula for each point. So this is OP. So if you're going to, where is OP? OP, distance, X, using distance formula, X minus 0 squared plus Y minus 0 squared. Okay, which is equal to 25 multiplied by X minus 3. Okay, X minus 3 squared plus Y minus negative 2. The distance between between these 2 points. Distance between these 2 points and distance between these 2 points. Okay. Of course, we need to simplify. We need to remove the grouping symbols there, simplifying the equation. So this is X minus 0 squared plus Y minus 0 squared, which is equal to 25 multiplied by X minus 3 squared plus. So that's the negative of negative 2 is positive 2. Okay, so I'm gonna rewrite this. Okay, this one. So this is our last equation. So simplifying this equation, this will be X squared plus Y squared. So since this is 0, so we do not necessarily to write 0 here, which is equal to 25. Then expand X minus 3 squared using our concepts from special products in algebra, in elementary algebra. So this will be X squared minus 6X plus 9 plus Y squared plus 4Y plus 4. Okay. So distributing 25 to the to all the terms inside the parentheses. So this will become X squared plus Y squared, which is equal to 25 times X squared, that's 25X squared, minus 25 multiplied by negative 6X, that's negative 150X, plus 25 multiplied by positive 9, that's 225. plus 25 times y squared, that's 25y squared, plus 25 multiplied by 4y. Okay, so this is 100y. Okay, and 25 multiplied by 4, that's 100. Okay, so therefore, simplifying your equation, this will be, so this is, this is 0. So the transpose x squared and y squared to the other side of the equation, this is 0, which is equal to 25x squared minus 150x plus 225 plus 25y squared plus 100y plus 100 minus quantity x squared plus y squared. Remove again the grouping symbols. Distribute the minus sign here to all the terms inside the parentheses. So this will become 25x squared minus 150x plus 225 plus 25y squared plus 100y plus 100 minus x squared minus y squared. Okay, so simplifying your equation, combining similar terms, so this will be, or the required equation is 0, which is equal to 24x squared minus 24y squared plus 150x plus 100y plus 325. Or the other it's also the same as 24x squared minus 24y squared minus 150x plus 100y plus 325, which is equal to 0 by commutative property of equality. Okay, so let's check your understanding here. So we're going to find the equation of the locus of a given point given the following conditions. Okay, so if you need more time, you just need to pause the video. Okay, let's check. Okay, so for number 1, the answer is your equation is y, which is equal to x. Number 2, the required equation is 3x minus y plus 7, which is equal to 0. And for number 3, we have 3x squared plus 3y squared plus 20x minus 34y plus 103, which is equal to 0. Okay, so did you get all 3 correct answers? Okay, so if you don't have any questions, then I will see you in our next lesson. Thank you for listening.